Hey guys, James coming in with another video. In this video, I want to talk about how we can change a quadratic equation in standard form into a quadratic equation in vertex form or a quadratic equation in intercept form. Now, in looking at the standard form version of a quadratic equation, what we really need to know how to do is find every value that is of interest to us or that could be of interest to us. Now, specifically, when we're looking at a quadratic equation, right, so this is the coordinate plane here, this is the x-axis, and this is the y-axis. When we have a quadratic equation, and say two of the lines in the quadratic equation cross the x-axis down here, those are going to be the x-intercepts, right, because they're intercepting the x-axis, which is this line right here. They're intercepting it. Equally, we could have a quadratic equation like this, and in that case, we're going to have imaginary numbers. They're not going to be crossing or intercepting the x-axis down here, okay, so we're not going to have any value down here, okay? We're not going to have any real x-intercepts. Now, in looking at this, I'm assuming in going into this lesson that you guys know that this is the vertex. Okay, I'm assuming that you guys know that this right here is the axis of symmetry. I'm assuming that you know these values are the x-intercepts. And I'm assuming that you know where the line crosses the y-axis is the y-intercept. So really, in looking at this, you have 1, 2, 3, 4, 5 different points, 5 different values that could be of interest to us. And if we were to plot more points along this quadratic equation, we could start to have a higher resolution of really what it looks like. And in that case, we could find 6 points, 7 points, 8 points, etc. And we may do that. But really, these are the main things that are going to be of interest to us right now with these quadratic equations. Okay, and the quadratic equation can be written in different forms, and each form has their positives and negatives, okay, as far as things that are better in one form or not better in another form, etc. They will help you in different areas. For example, in vertex form, you can easily find the vertex just by looking at it, by taking the opposite of what's inside the parentheses here, right? So if this h, for example, was a 9, we would have a positive 9, which is the opposite of negative right here. So the sign would be positive 9, and then we just keep the value here, whatever k represents. Say if it represents 7, the vertex would be positive 9 and 7, okay, meaning positive 9 on the x-axis, and then 7 on the y-axis. So with that aside, let me erase this. With that aside, you want to know how to transform this one equation, this quadratic equation in standard form, into a quadratic equation represented in vertex form, or represented in intercept form. And in each one of these forms, you want to know how to find out all the points of interest within a quadratic equation that we might want to know. So with that said, let me go ahead and show you how to translate the quadratic equation in standard form into a quadratic equation represented in vertex form. Now, how we do that is by completing the square. In completing the square, what we want to do is try to get the first value here, which in this case is 2, to 1. So what we're going to do is we're going to factor out a 2. When we factor out a 2, we really are just dividing each one of these values by 2. We're going to write the 2 outside of parentheses. We're going to have an x squared plus 9x. And then we're going to leave a lot of space between here, okay? Because we're going to write some stuff in this middle section here. And we're going to add the last value down here, which is the 36 divided by 2. And we're going to say plus 18, okay? What we're going to do from here is we're going to have to write a value in here. And you say, okay, well, where does that value come from? Well, it comes from taking this middle value here, dividing it by 2. Okay, so what's 9 divided by 2? Okay, 9 divided by 2 is just 9 over 2. And what we're going to do after we divide it by 2 is we're going to square this. This whole thing gets squared. And then we're going to put a plus sign in front of it and a negative sign in front of it as well. Alright, so you divide whatever the middle value is by 2. You square it. And you're going to put a plus and minus before each one of those. Okay, you say, okay, well, where do we put them? Where do we put these two different values? Okay. Where we put them is right here. We're going to say plus. The plus always goes right here. Plus 9 over 2 squared. We're going to close the parentheses. And then on the outside of the parentheses, we're going to head and say negative 9 over 2 squared. From here, we just want to bring down the 2, open the parentheses. We're going to take the first value, whatever this is, x, b, c, d, whatever. We're going to plug it in at the beginning. We're going to take the value right here. That's a plus or a minus, whatever it is. We're going to plug that in the middle. And then we're going to look at the area inside the parentheses that we just put in here to the right of the middle value. In this case, it's 9 over 2 squared. So we're going to say 9 over 2, close parentheses. We're going to take that squared and plug it in outside of the parentheses. Okay, so that's how this gets converted to this. And then from that, we're going to take 9 divided by 2, and we're going to square that. So again, 9 divided by 2 times 9 divided by 2, and gives us 81 over 4. And there's a negative in front of that, so really this is going to be translated into negative 81 over 4. So we have negative 81 over 4 plus 18. And that gives us negative 9 over 4. We're going to take the 9 over 4, so we really just added these together. It gives us 9 over 4. We're going to multiply 9 over 4 times 2. So negative 9 divided by 4, which gives us negative 9 over 2. Okay. And really, to write this more clearly, we're going to have, f of x equals 2 times x plus 9 over 2 squared minus 9 over 2. Alright, that's really what this equation is here. Now this, up here, is a quadratic equation in standard form. This is the same quadratic equation, but represented in vertex form. Now you may ask, well, so what's the vertex here? The vertex is negative 9 over 2, 9 over 2, and negative 9 over 2. That's what the vertex is. If you were to work out the vertex for this, it'd be the same thing. Okay? So that is the same equation as this, but written in vertex form. Vertex form. Okay. So you can see the process. Right, so the process, I just went ahead and converted this to 1, right, by factoring each one of these by 2. It gave us the 2 and the x and the 9x, right? We left some space, put in 18 plus 18. We divided the 9x by 2, which gave us 9 over 2, and we had a plus 9 over 2 and a minus 9 over 2. We took the plus 9 over 2, placed it right after the middle term of 9x, right? And then after we did that, we closed the parentheses. And on the outside of the parentheses, that's where the negative 9 over 2 came. Excuse me, negative 9 over 2 squared. Each one of these is squared. Plus 9 over 2 squared, negative 9 over 2 squared, negative 9 over 2 squared gave us negative 81 over 4. Negative 81 over 4 plus 18 gave us negative 9 over 4. And then we took the negative 9 over 4. I didn't write that out. I'm just showing you here what we did is we took this, we added it by 18, okay? In adding both of these, it gave us negative 9 over 4, okay? And then we took this and we multiplied it by whatever is in front of the parentheses here. Okay, in this case, it gave us negative 9 over 2. If there was nothing here, we would not multiply it. We would just keep it as is. Okay, if you finish what's outside the parentheses, if there's a number before, like you factored out something previously and it's outside the parentheses, you need to multiply it by what's out here. If there's nothing here, again, it would just be negative 9 over 4. In this case, we multiply by 2. We have negative 9 over 2. Okay, from that, we brought down the 2. We brought down the x, we brought down the middle sign, so it's just x plus, x plus, x plus. We took in this value right here, 9 over 2, boom, plus 9 over 2. The squared gets put on the outside of the parentheses, and then this value in here, which after we multiplied negative 9 over 4 by 2, that gave us negative 9 over 2, and the negative 9 over 2 is really what goes here. Okay, so that's really how you get, this form. Okay, this is the same thing in vertex form. Again, what you want to know is that in order to find vertex form, that's why it's called a vertex form, because it easily gives you the vertex, like what I was saying earlier. Just take the middle value in here, flip it, and keep the second value in the parentheses. So we have negative 9 over 2, and the outside one stays the same. Don't flip anything. Negative 9 over 2. All right, so that's the vertex. Okay? Now, from that, what I'm going to do is I'm going to take the same standard form equation and try to turn it into the intercept form, okay? So again, standard form, I converted that to vertex form. I'm going to convert standard form again into intercept form. So what we have here is we have a 2x squared plus 18x plus 36, okay? So I'm just going to try to factor this. I'm going to say 36 times 2. It's going to give me a 72, okay? I'm just going to go through the factors of 72 and try to see which one of these, whether plus or minus, in either scenario, will add up to positive 18, okay? So 72 divided by 3, 72 divided by 4, 72 divided by 6. All right, so 72 divided by 6 looks like it gives me the factors of 18. 12 plus 6 equals 18, or in this case, 12, positive 6 plus positive 12 equals positive 18. Now, this is going to be a factor by grouping scenario. What I want to do, I'm going to keep the 2x squared. I'm going to add each one of these in place of the 18, right? So we were trying to find two values, whether plus or minus, that added up to the 18 value in here. We found those in this and this. This is an x value right here, so each one of these is going to be an x as well. Okay, so we're going to take this, we're going to say plus, because they're both positive, we're going to say plus 6x, okay, and then plus 12x plus 36. Draw a line in between the middle. Okay, and we're going to factor by grouping. Okay, in this case, I can take out a 2 and an x. There's an x on either side. I'm going to take out a 2x, open the parentheses. I'm going to pull down an x in this scenario, pull down the plus, and then 6 divided by 2 is obviously 3, so we have a 3 on that side. On this side, I can take out a 12, only a 12, so I'm going to take out a 12, open up my parentheses. The 12 has been taken out, so it's just an x plus, and 36 divided by 12 is 3, so that's what the factoring by grouping gives me. I'm going to go ahead and bring both of these values down. So we have a 2x, right, 2x, this is a positive, not a negative, 2x plus 12 times x plus 3 over here. And then again, can I factor this anymore? Yes, I can. I can take out a 2 on either side. So really what we're going to have is we're going to have a 2 on the outside, x plus 6. So 2 times x plus 6 times x plus 3. Okay, that's really what we have here. What we want to know how to do here, guys, we want to find each one of those key characteristic points. I can write them out again. We want to find x-intercepts, right? We want to find axis of symmetry, right? Axis of symmetry. We want to find vertex. We want to find y-intercepts. And we want to find another x value, okay? In converting each one of these, let me just go ahead and write this as, right, so we have intercept form, we have vertex form, and finally standard form. From each one of these guys, what we want to know how to do is to find each one of these main points of interest. So let me go through how to do that specifically for each one, okay? And you'll just see how it's done. With the standard form, okay, there's going to be a way that we can find the vertex. Specifically, there's a formula that will allow you to do that. It'll be negative b over 2 times a. Okay, that's the formula, negative b over 2a. So if we pull in, as you can see, a, b, c, the values, this is an a, b, c. We're going to pull in the b value, but we're going to have a negative, obviously, because that's what the formula says. We have a negative 18 over 2 times 2. Okay, so 2 times 2 is 4. So negative 18 divided by 4 gives us negative 9 over 2. Okay, and technically that's how we find the axis of symmetry. The axis of symmetry is going to be the middle point right here, right? So technically, I misspoke, said vertex. This is actually the formula for standard form that gives you the axis of symmetry. And as you can see down here, in vertex form, we really have the same thing. So we have axis of symmetry here, and then in vertex form, pulling out the axis of symmetry here. So the opposite, again, like I was telling you, opposite of this is going to be negative 9 over 2, which is the x value, and then negative 9 over 2 again is the y value. Axis of symmetry indeed is negative 9 over 2. Now we can take the negative 9 over 2, plug that back into the x values in the standard form, multiply that sucker out, and it will give us the vertex. So technically, for standard form, axis of sim is negative 9 over 2. We've done that in standard form. Now, we want to find the vertex. So I'm just going to take this value in here. I'm going to take this times negative 9 over 2 squared plus 18 times, sorry, let me write this down here. I'm just plugging in this value into all the x values of the standard form. So negative 9 over 2, and then what do we have? Plus 36. All right, and if you work this out, we have negative 9 divided by 2, negative 9 divided by 2 squared, which gives us 2 times 81 over 4, plus 18 times negative 9 divided by 2, which literally just gives us negative 81 plus 36. Okay, so we have 2 times 81 divided by 4, which literally just gives us 81 over 2 minus 81 plus 36. Now if you do this, 81 divided by 2 minus 81 plus 36, it gives us negative 9 over 2. Okay, so really, in plugging that into each x value up here in standard form, you came out with, after all that hoopla, you came out with negative 9 over 2 here. Now this is the y. Okay, this is the y value. So if you really bring both of these values down, right, you bring both of these down, you're going to have the x and the y value of negative 9 over 2 and negative 9 over 2 again, which is, again, is the exact same thing as just looking at it in vertex form and saying, okay, negative 9 over 2, and then negative 9 over 2 again. Really, remember I was telling you, switch the sign in the middle of the parentheses, so this would technically turn into negative 9 over 2, right? And then we have a negative 9 over 2 here, right? So that's negative 9 over 2, and negative 9 over 2 is the exact same thing as negative 9 over 2, negative 9 over 2. So, really, we found the vertex in standard form as negative 9 over 2, and negative 9 over 2 down here. Okay. Now, technically speaking, if you wanted to find the x-intercepts for something that's in standard form, so we can find the axis of symmetry in the vertex, right, by going through the whole hoopla that we did in standard form. To find the x-intercepts, guys, what we really need to do is really just solve it in one of 3 ways. You can solve it by factoring this sucker out, okay, and factoring it will put it into intercept form, and then from there you can set these different values to 0 and find the x's that way, okay. You can complete the square, transform this into vertex form, okay, and then from that you can solve for the x by setting the y to 0, solving for the x. That will give you the x-intercepts, or you can plug the a, b, and c values here into the quadratic equation and find the x's that way. So there's multiple different ways to do this. Let me take this page off because we are running out of room. There's multiple different ways to do this. Okay, first of all, I'm going to actually, let's see here. I think I'm going to go ahead and do it in the vertex form. So instead of translating into vertex form all over again, I'm just going to take this vertex form, rewrite it here, set the y to 0, and solve for the x values, okay? So let me just do that real quick. So we have f of x equals 2 times x plus 9 over 2 squared minus 9 over 2, okay? That's the equation here. What we're going to do is we're going to take this 2 times x plus 9 over 2 squared minus 9 over 2 equals 0. And we're going to just solve until we get the x, okay? So in this case, I'm going to rewrite it. 2 times x plus 9 over 2 squared equals 9 over 2, positive 9 over 2. Again, what we just did here is we added 9 over 2 to each side, so that canceled this one out, and really it was just put on the other side of the equal sign here, other side of the equation. I'm going to divide that by 2, divide this by 2, so 9 divided by 2 divided by 2 is going to be 9 over 4. So really what we're going to have here is x plus 9 over 2 squared equals 9 over 4. Okay, we're going to undo this by radical symbol. We're going to undo it by the square root, and when we do that in an equation, we're going to have a plus and minus sign here. So really, we have x plus 9 over 2 equals plus or minus the square root of 9 over 4. And from that, we can go ahead and subtract 9 over 2, bring it down. We're going to have negative 9 over 2 plus the square root of 9 over 4, which the square root of 9 over 4 is really just going to be 3 over 2, okay? So it's really going to be plus 3 over 2, right? Or we're going to have negative 9 over 2 minus 3 over 2. So that's going to be our x-intercepts. We can go ahead and plug that into the calculator. So we can say negative 9 divided by 2 plus 3 divided by 2, and that gives us negative 3. Okay, so this one right here is really just going to be an x value of negative 3, and this over here is really going to be negative 9 divided by 2 minus 3 divided by 2, which really just gives us a negative 6. Okay, so this one down here, negative 6. So it's, it's x equals negative 3, or x equals negative 6. Okay, so that's a way to do that here. So let's go ahead and plug that in. So we have x equals negative 3, x equals negative 6. Let's plug that into the values up here. Okay, we have the x-intercepts, negative 3, negative 6. Okay, so from standard form, we went ahead and converted it to vertex form, and then solved for the x. For the x's here, we plug that in here. Okay, negative 3, negative 6. Our axis of symmetry is negative 9 over 2. Vertex, negative 9 over 2, negative 9 over 2. Y-intercept. We can go ahead and solve for the y-intercept again by, using the same vertex form, and just go ahead and setting the x to 0. So really what I could just do here is say, f of x equals 2 times 0, right? Set to 0 plus 9 over 2 squared minus 9 over 2. And again, that this is something that you could literally just put in your calculator. So 2 times 0 plus 9 over 2 squared minus 9 over 2 gives us 36. Okay? You can do that by hand as well if you wanted to, but anyways, it's very, very simple. Just, it's very simple. We're just squaring the sucker, multiplying by that, and then subtracting by this. Gives us 36. Okay? So, for the y-intercept, you can say, okay, well, y-intercept is equal to 36, and then we say, okay, well, we want to plug in another x value, so let's do that. Let's plug in. Okay, when we were up here, remember how we plugged in the negative 9 over 2, right, to find the y output of where x equals negative 9 over 2, we found the y output of negative 9 over 2. Alright, so that's our vertex. This is the x, that's the y. We can plug in a different value. Instead of negative 9 over 2, we can say, let's plug in negative 2. Okay, so let's take this exact same thing. We'll pull it in down here. We're gonna say, let's see here. 2 times negative 2 squared plus 18x. Sorry, plus 18 times negative 2 plus 36. Negative 2 squared is 4. So really what you have here is 2 times 4. This whole thing that's 4. This is 2. So 4 times 2 is 8. Okay. Plus 18 times negative 2, which is going to be negative 36 plus 36 equals negative 36 plus 36 is 0. So really, this is just going to be equal to 8. Okay. Again, we can just, plug that in here just so that you can see, right? So we have 8 minus 36 plus 36 is just equal to 8. Okay, so y, where x is negative 2, y is equal to just 8. Okay, where x is negative 2, y is equal to 8. That's all the points of interest for us, really. And if you wanted to, we can go ahead and graph this out. All right, so we have a coordinate plane. Right, we can go ahead and graph this out. We have x of negative 3, x-intercepts negative 3, negative 6. So let's just go ahead and say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's the x-intercepts. The axis of symmetry is negative 4.5. 3, 4. Okay, so 4, and that's really what negative 9 over 2 is. Right, so if you take, again, if you take negative 9 divided by 2 and just hit it in decimal form, it's negative 4.5, which, again, you can see is indeed the halfway point between this. So this is negative 3, that's 4, 4.5 is right here. Okay, so that is indeed halfway between 6 and negative 3. If you want to prove it, you can just say negative 6 plus negative 3 divided by 2, negative 4.5, which is indeed halfway between negative 6 and negative 3. Okay, so with that said, let's go ahead and plug in the vertex. So the vertex is going to be negative 9 over 2 again. So it's negative 4 over 5. Vertex negative 4 over 5. 1, 2, 3, 4. Vertex is going to be right right here. But let's go ahead and look at this. The a value, obviously, even if we didn't write this down, we can look here and say the a value is a positive. So in that case, we know that the parabola is going to open up. And since we know, obviously, we didn't need to do this, but we can say, okay, well, it's down here. It's obviously going to be opening up like that, okay? Any other values that we can have in here? Okay, so we have y is equal to 36. So if we kept going up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, somewhere up here is where this would actually come up and intercept that y-axis right here. Right, so it'd be something sort of like this. I mean, that's sort of a crude drawing of it, but coming in steep, smacking off that sucker and going back up steep, crossing at, y is equal to 36 up here. The other x value, what did we put in? We said at -2, the y was equal to 8. So let's see, at -2, this is -1, that's -2. If we go up, the y value here, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that holds true. So at -2, y is equal to 8. -2, y is equal to 8. Is there anything else we can put in? We put in the x-intercepts. We put in the axis of symmetry, which was -4.5 or -9/2. We have the vertex. We have the other y value, the y-intercepts. We have 1, 2, 3, 4, 5, 6 different values of interest here. We have 1, 2, see here, 1, 2, 3, 4, 5, 6 different values of interest here. So yeah, I mean, guys, that's all the points of interest done by standard form. Now, it's definitely going to get easier if you can do this in intercept form. That's definitely probably the easiest way to go about it. And if you can get it in this form, it's going to be the easiest. But with that said, you didn't have to translate this into vertex form and solve for the x and y values. You could have just used, for the x-intercepts, you could have used the quadratic formula. But then again, I wanted to show you how to find the y-intercept by using the vertex form. I just wanted to show you that, but again, you understand that in standard form, the y-intercept, indeed, guys, is the last value in standard form. So the 36 here is indeed the y-intercept. You didn't even need to put, solve for the y-intercept in vertex form, but I wanted to show you how to do that. In vertex form, if you're looking at vertex form, I can show you how to get all these values. Again, the x and y value is going to be the same. Like, we're going to go through this exact same process to get the x-intercepts and the y-intercept, right? That's how you would do it in vertex form. In this case, you could have just used the quadratic formula, or you could have converted it to vertex form or intercept form, and then solve the x's that way, okay? But I'm going to go through vertex form. I'm not going to go over the x's again or the y's again, because we've done that, right? So we know how it's done. I might briefly rehash it, but I mean, I think we know how that's done. We know how to find the vertex in vertex form, okay? And we know how to get the axis of symmetry, because really it's giving the axis of symmetry here, which is the x and y values, and we can just plug in another value in here to get another x value. So it's quite simple, guys. It's quite simple. Let me go ahead and switch this over, and I'll do it in vertex form. I'll do it in vertex form real quick. So what do we have here? We have f of x equals 2 times x plus 9/2 squared minus 9/2. Now we know, okay, to get the x-intercepts, we're going to set this equation, squared minus 9/2, to 0. And again, by doing that, you just had x plus 9/2 squared is equal to 9/2. We divide this by 2. We divided 9 divided by 2 divided by 2 gave us 9/4. So we had x plus 9/2 squared is equal to 9/4. Right, and then from there, all we had was the square root of that to get rid of that, square root of this, plus or minus. So really you had x plus 9/2 is equal to plus or minus the square root of 9/4, which the square root of 9/4 is equal to 3/2. So plus or minus 3/2. Alright, and we're just subtracting the 9/2 here, bringing it over to this side. So we have negative 9/2 plus 3/2 is equal to something, and we have negative 9/2 minus 3/2 is equal to something else, right? And you can just say negative 9 divided by 2 plus 3/2, again, equal to negative 3. And this one, again, is equal to negative 6. So we have x equals negative 3, x equals negative 6. And again, if it was in vertex form, you would do this to find your x-intercepts. This is a -6. And that is the same as here, x-intercepts -3, -6. Right? Axis of symmetry, it's clearly seen within the vertex form. Like I was saying, go ahead and flip this one. So we have a -9/2 and then -9/2. That is the x and y values, guys. This is the x value. That's the y value. If this is the vertex, okay, if the vertex is going to be this, for this specific equation, it's actually going to be, something like this. Okay. If it's giving the vertex is the max or the min point, guys, of a parabola. So if this is vertex form and it's giving the x and y value, you know that the x value is going to be the center. Otherwise, you wouldn't be able to go and get the vertex on the y value. Okay? So this is the axis of symmetry. Okay, the axis of symmetry, since it's clearly seen within here, you can see that it's seen within here. -9/2. Flip this sign, what is that? -9/2. So we have that. We also have the vertex, -9/2 and -9/2. What do we have here? -9/2, -9/2. And again, if you don't have the y value in here, go ahead and set the x to 0, and then solve. Okay, which is really, just to be a little bit quicker, I can go ahead and just say 2 times 0 plus 9/2, right, squared minus 9/2. You can see that's 36. So when you set the x to 0, you're going to get your y-intercept. And again, that's 36. Okay, and if we want to put in a different value within here, we can do that for any one of these forms. Okay, let me just, to be a little bit quicker, let me just go ahead and do that here. So we're going to have 2 times -2 plus 9/2 squared minus 9/2, and this should be 8. Okay, it is 8. All right, and that's the value at x, where x is -2, y is equal to 8. So really, we have all our same, all 6 points. We just now got all 6 points of interest from this vertex form right here. Fairly quickly. I like vertex form. I really do, because you have your vertex, you have your axis of symmetry. You have a fairly simple way of finding the y-intercept by setting the x to 0. You can plug in any other x value to find whatever the y value is in here. And then really the hardest thing that you're doing is really just setting the y to 0 to solve for the x, which gives you the, x-intercepts. Fairly quick, fairly easy to do. Last but not least, guys, is going to be intercept form. Now, this is the last thing, the kicker. I told you I was going to help you guys find all the common points of interest in each one of these forms. We started with just this on the paper. We went from this on the paper, to that on the paper, to this on the paper, and with each one of these, standard and vertex, we found each one of these points of interest in both. Last but not least, guys, we're going to do intercept form, okay, which in this case, the intercept form came from grouping the sucker, right? So when we grouped this sucker, we went from this down to this. We found factors of 6 and 12, etc., down to this. So let me go ahead and, if you want to rewind the video and watch that part, you can. But we have 2 times x plus 6 times x plus 3. So what we can go ahead and do here is set each one of these equal to 0. Now, I know that if all we have is x plus 6 or x plus 3, equaling this to 0 is just going to be the opposite of whatever's in here, and I can just prove that by saying x plus 6 equals 0, and then if we want to complete the equation, we're going to subtract 6 on that side, subtract 6 on that side, x equals -6. So really, it's just -6 is obviously the opposite of +6. The same thing with 3. Now, if you have like a, anything more complicated, like if you have 8x, plus 3 minus 6, or whatever you have in here, you're going to have to actually probably work that out and set it equal to 0. But in this case, it's fairly simple just to see that each one of these is going to be the opposite of what's in here. Okay, so we have an x-intercept of -6, and an x-intercept of -3. -6 and -3. To go ahead and find the axis of symmetry, we're going to take both of these. So we're going to take -6 plus -3. We're going to divide that by 2, which is going to give us -4.5, which again is going to be the axis of symmetry in the middle of -3 and -6. Okay, once we have -4.5, or you can write it in the fraction form, either way, same thing as -9/2. Take this, plug that back into the original equation, to get your vertex. Now remember, with vertex and the y-intercept, when you plug it back into your original equation, you're going to have to solve the whole thing, not just what's in here. Okay, you're going to have to multiply it by 2 as well, okay? We're going to take 2 times negative, let's just write in fraction form, negative 9 divided by 2 plus 6 times negative 9 divided by 2 plus 3. And that gives us a vertex of negative 4.5, or negative 9 over 2, okay, which is the exact same thing we had here. Axis of symmetry of negative 4.5, okay, and the vertex of negative 4.5, or negative 9 over 2. So the vertex is, you can say negative 4.5, negative 4.5, or you can write it as negative 9 over 2, negative 9 over 2. That's the vertex. That whole thing is the vertex. This, in and of itself, the x value, so this is the x value, that's the y value. This is the axis of symmetry, okay? So we have, what do we have here? We have our x-intercepts. We have our axis of symmetry. X-intercepts is negative 3, negative 6, negative 3. Negative 6, negative 3. Axis of symmetry, negative 4.5 or negative 9 over 2. Axis of symmetry, negative 9 over 2. Vertex, negative 9 over 2, negative 9 over 2. Vertex, negative 9 over 2, negative 9 over 2. Really, all we have left here is the y-intercept and the other value of a negative 2. So to get the y-intercept, guys, go ahead and just set the x's equal to 0. And multiply these across, and then multiply it by 2, right? So really, just to save time, I'm going to just say 2 times 0 plus 6, right? Times 0 plus 3, right? And that gives us 36, which again is the y-intercept of 36. And again, you know, if you knew that you were just going to set these to 0, you could have just, to make it quicker, you just said 6 times 3 times 2, which is 36. Okay, so we have all the values down here so far in intercept form. We're looking for this one right here. To save time, I'm going to do that again. I'm going to say 2 times negative 2. We're plugging in the negative 2 for the x value, guys. Plus 6 times negative 2 plus 3. Boom, 8. Where x is equal to negative 2, the y output is going to be 8. Okay? Where x is equal to negative 2, the y output is positive 8. I meant to say positive, not negative. Okay. So, with that said, guys, we have successfully gone through each one of these forms, standard form, vertex form, and intercept form. And we have successfully gone through and found every point of interest, right? Every point of interest that we could possibly need, that we can possibly want. It's not a lot of work. It's quite quick. It's quite fast. But in explaining it and teaching it, that's why we were going definitely slower. So with that said, guys, this is the Math Magic YouTube channel. Oh, I said I was going to show you a special way, okay, a special way to see the graph of a parabola without using any of this, just using the vertex in each one of these forms, so you don't have to go through each one of these, you know, points and find each one of these things out. You can just, like, find the vertex and then figure out what the graph looks like. I will actually make that in a separate video, though, because it is quite awesome. I'm just going to have that in a separate video, and if you want to watch that video, it's just going to be a few minutes long, and you'll know how to do it, instead of, like, having it at the end of this super long video. So, with that said, guys, I will see you in the next one. Bye.